Hi, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is a supplemental resource to anyone who may be needing some extra help in their chemistry classes. This week, I'm going to be doing an intro on chemical reactions, so talking about different phases, phase changes, chemical changes versus physical changes. So if you need any kind of clarification or help with those topics, feel free to keep on watching. And without further ado, let's get started. So I'm first going to go over the different states of matter and just give a little detail about each of them. So we have solids, liquids, and gases, and each of these states of matter has specific characteristics. So I'll first start with solids. In a solid, the molecules move very slowly. They're very close together, just like this diagram. And they cannot spread to fill a container, and they are not compressible because of how close and congested the molecules are. Next, we have liquids, which are kind of like the intermediate state of matter. The molecules in a liquid move at a medium speed, and they are at a medium distance apart from each other. They can spread to fill a container, like if you've ever poured water into a cup, it obviously spreads to fill the shape of the cup. However, liquids are not compressible. If you push down on a cup of water, the water will not shrink, it will just move up above your hand. Then we have gas, which is at the opposite end of the spectrum from a solid. The molecular motion is very fast, the molecules are spaced out a lot. Gases can spread to fill a container, and gases are also compressible. So if you shrink the volume of a container, the pressure of a gas will increase and you can compress the gas. And again, there are my diagrams. So as you know, with melting and freezing and stuff like that, you can go in between these different states of matter with phase changes. So I've created a little diagram. This diagram shows the different terms for the different phase changes going from each kind of state of matter. So to go from a gas to a liquid is to condensate, liquid to a gas is to evaporate, a solid to a gas is sublimation, a gas to a solid is deposition, a solid to a liquid is melting, and a liquid to a solid is freezing. I feel like sublimation and deposition are the ones that can most easily get forgotten. I always like to remember that sublimation is from a solid to a gas, so kind of the S's go together, and then deposition is just the other way. So now I'm going to discuss chemical reactions versus phase changes, and this is going to be an important concept for the rest of our unit where we start talking about chemical reactions, because those are chemical changes and / reactions, and it's important to make this distinction. So when you have a chemical reaction or a chemical change, you form new substances. You start with reactants and you end with products, and we'll discuss this more when we talk about chemical equations. You can also not reverse a chemical reaction. And also chemical reactions usually give some visible indication that a chemical change has occurred, such as a color change, bubbles or gas given off, heat or light, or formation of a solid. Then we have physical changes, and this is usually when no new substances are formed. Most often they are just a change of state. And they are reversible because, for instance, when you go from a solid to a liquid, you can go back from a liquid to a solid. For instance, melting a popsicle is an example of a physical change, because you can just freeze it again and it will reverse back to its original form. So chemical reaction, new things form. Physical change, nothing new is formed, usually just a change of state. Okay, so our final point of discussion on this very concise video is an intro to chemical reactions. So like I briefly mentioned earlier, in a chemical reaction, which is an indication of a chemical change, there will usually be a chemical equation which has both reactants and products. Reactants are what you start with. They are on the left side of the equation, and products are the final material. So they are the new substances that are formed, and they are the indication of the chemical change. So an example is baking soda and vinegar. So we start with baking soda and vinegar, and those two things have specific properties. Baking soda is white, it's a solid, it's powdery, and vinegar is clear, colorless, and it's a solution. So during the reaction, we get bubbles, and that is the indication of a chemical change, like I mentioned earlier. And then we have products, new substances with new properties. That is a big thing of recognizing that new substances were formed, is that they don't have the same properties of the substances you started with. So because what occurs with baking soda and vinegar is a chemical change, we can write a chemical equation for it. So we have sodium hydrogen carbonate plus acetic acid yields sodium acetate plus water plus carbon dioxide. Sodium hydrogen carbonate is baking soda, acetic acid is vinegar, and as you can see, they yield new substances. And when you put an arrow in chemical reactions, that means yields. It does not mean equals, it does not mean goes to, it just yields these products. And as you can see, especially with the number of, especially with the different compounds indicated below, that it is clear that new substances were formed in the reaction. I also had a typo with the formula of sodium acetate, so that is why there's a scribble over there. It should be NaC2H3O2. So we can see in the reaction, new substances were formed. That means there was a chemical change. So also another important thing to note is the law of conservation of mass, which I'm going to continue to elaborate on, but this is like a good instance of it playing its part. If you notice, the number of atoms of each element is the same on both the reactants and the product side of the reaction. So on both sides, we have 1 sodium, we have 5 hydrogens, we have 3 carbons, and then we have 5 oxygens. And that is important because the law of conservation of mass says matter cannot be created or destroyed. So whatever you start with on the reactants, even if it's a different order, everything that showed up in the beginning of the reaction must show up in the end. And this also plays a part in the mass of the reactants and the mass of the products. So the total mass on the left side of the equation will equal the total mass on the right side according to the law of conservation of mass. So for example, if we had that sodium hydrogen carbonate equaled 84 grams and acetic acid equaled 60 grams, those were the masses of the reactants. And then we had the mass of some of the products. For instance, if NaC2H3O2 had a mass of 82 grams and H2O had a mass of 18 grams, we can calculate the mass of CO2 because 84 plus 60 must equal what is on the products, which is 82 plus 18 plus the mass of CO2 because of the law of conservation of mass. So we can subtract 82 and 18, which is what we already have on the products, from 144, which we know is going to be the total mass of the products because we got it on the reactants, and we get 44 grams of CO2. So that shows the law of conservation of mass in full force. You will always have the same mass on both the reactants and the product side. The circumstances will be a little bit different when we get to stoichiometry and you have it limiting and excess reactants, because then you'll have too much of one reactant. But in this sense, the mass of the reactants will always equal the mass of the products because of the law of conservation of mass. And finally, I just did a little notation over here. Solids are represented as S, liquids as L, gas as G, and solution as AQ, which means aqueous. And these are what is often written in parentheses on a chemical equation to show the state of the compounds we are talking about. And that concludes everything that I've talked about in this video. So I hope you enjoyed this week's video. Next week, I'm going to start talking more about chemical reactions. So feel free to join me next week if you are confused on those topics. I'm going to leave a link in the description box to my website if you would like to schedule tutoring with me. And as always, you can leave any questions you have in the comments, and I will do my best to answer them. I hope you enjoyed this video, and good luck with learning the rest of your chemistry.